This is the second part of the second IB multiple choice paper. There's 40 questions. This is questions 11 through 20. You can get the link to the unanswered questions in the description below, and also the link to the playlist with the other videos for this paper. So we're on question 11. So a laser beam is directed at the surface of a smooth, calm pond. We've got an air-water boundary here. Which organisms could be illuminated by the laser light? Well, there's a difference in density here. And because there's a difference in density, then the laser would refract somewhat if it entered the water. So there's definitely no chance we could illuminate the pondweed because that's a straight line through, so that wouldn't happen. There'd be some refraction. Now, we could also get some reflection from the surface, so you could definitely illuminate the bird. You might get some refraction, where because water is more dense, the ray would bend towards the normal, so you could illuminate the fish. However, you wouldn't get reflection off the normal, and there's no way that the light would refract back in that direction, so you could not illuminate the crab. So bird and fish, A. Question number 12. The diagram shows an arrangement of resistors. What is the total electrical resistance? Well, it's probably easier if we draw this out again. So we've got 3 resistors going on one path and just one resistor on the other path. And then we've got X over here and Y over here. Whoops, Y over here. So every single one of those resistors is 10 ohms. So if we first add up the series, then that's a total resistance of 30 ohms up at the top, and that one's 10 ohms. In order to calculate the total resistance in parallel, we need to do 1 over 30 plus 1 over 10 equals 1 over R total. So that gives you 4 over 30 equals 1 over R total. So R total is 30 divided by 4, which is about 8 or something. So it'll be between 1 and 10 ohms, B. Which one of the following statements is correct? The force acting on an object is equivalent to, okay, it's talking about energy and momentum, so we're going to write out some equations. We know that the change in momentum equals the impulse, which equals Ft. Now here we want to find out what force is. So force would be impulse divided by time, or change of momentum divided by time, but not change of momentum on its own. But here, B, impulse it receives per second, so impulse divided by time. So B looks like the right answer. Let's just check the other two. The energy it gains per second, well, the energy it gains is the work done, which is the force times the distance. So it's the energy it gains per meter of distance, so it's not C. Or its acceleration per meter. Well, we know that F equals ma, but this is the force is the acceleration multiplied by the mass, so it's not that either. So the answer is B. Question number 14. If a single free neutron undergoes beta decay, the total number of particles after the decay is what? Well, we need to remember our beta decay equation, in which a neutron decays into a proton. We've got a balanced charge, so an electron or a beta particle is produced, and we've got a balanced lepton number, so also an electron antineutrino is produced. So that's 1, 2, 3 particles. C. Question number 15. Standing waves in an open pipe come about as a result of what? Well, if we have a pipe like this, for example, then we have one open end over here, so we have the wave travelling down here. It reflects from that boundary. Let's try again. Down here, it reflects from that boundary and comes back over here. And here, these are places where it's superposed. So we have a node or an antinode where waves meet and they superimpose upon each other. So reflection is happening and superposition is happening, so the answer is A. A fission reaction for uranium. Well, we've got uranium plus a neutron goes to barium plus krypton plus 3 neutrons, and we want to find out A and Z marked here in the krypton symbol. So the easiest way to do this is just to equate all the numbers on the top and the bottom. So on the top, we've got 235 plus the mass of a neutron, which is 1. And then we've got the arrow, 141 plus x, or in this case, a. Let's call it a. Plus, and then we've got 3 neutrons up here, so that must be plus 3. And then the proton number at the bottom, we've got 92 plus 0. Neutron doesn't have a proton number. Goes to 56 plus z plus 0 again, because more neutrons don't have proton numbers either. So if we want to calculate this, then we can say that that's 236 minus 141 minus 3 equals A, and down here 92 minus 56 equals Z, which gives us an answer of... Question 17. A feather is dropped from rest at a height of 9 meters above the surface of the moon. It takes 3 seconds to reach the surface. Based on this observation, what's the best estimate for acceleration? Well, this is a SUVAT question. So you've got height is 9 meters. The initial speed is the initial speed is 0 because it's dropped. The time is 3 seconds, and you want to find the acceleration. So s equals ut plus a half at squared is the equation with all those values in. U is 0, so 2s divided by t squared equals a. So that's 2 times s, which is 18, divided by 3 squared, which is 9, equals a. And that gives us an acceleration of 2 meters per second. Question 18. A transverse wave travels from left to right. The graph below shows how, at a particular instance of time, the displacement of particles in the medium varies with position. Which arrow represents the direction of the velocity of the particle? So basically, which way is the particle moving at that moment in time, in which direction? So we can rule out a couple to begin with because we know it's a transverse wave. So the vibration of the particle is perpendicular to the direction of motion. So the wave position, the wave seems to be traveling that way. So the it says, sorry, from left to right, so the wave is traveling that way. So the particles must move perpendicular to that, so it can't be B or D. So is it A or C? Well, if the wave is traveling this way towards the right, then soon this position will be here, and this position will be here, and so on. So it's moving that way. So if the particle P is soon going to be where the particles behind it are, then the particle P will soon be down here. And so the answer must be C, because it's moving downwards because it's got to get to that x-axis. So C is our answer there. Question 19. The average surface temperature of Mars is about 200 K. The average surface temperature of Earth is about 300 K. Both can be regarded as black bodies. What is the ratio? Okay, so we need the power emitted equation here. So P equals the emissivity times a constant times the area times T to the 4. The energy radiated per second is the power, but we also want per unit area. So we're looking for P over A is E sigma T to the 4. So basically this value here is proportional to T to the 4. So the temperature on Mars, so 200 to the 4 over 300 to the 4 gives us the correct ratio there. So 2 to the 4 is 16. 3 to the 4 is 81. 16 divided by 81 is 0.19, which is about 0.2. D. Question 20. The diagram represents an aircraft of length L, wingspan x, flying horizontally at a speed v in a region where the Earth's magnetic field of uniform flux density B is inclined at an angle. Okay, so we're just looking for the magnitude of the EMF generated here. Now, from your data booklet, if you wanted to use your data booklet, well, you don't really need to because you're basically given the equation down here. But from your data booklet, EMF is BVL. Now, that works if the wire or the conductor is at right angles to the field. Now here our conductor is not at right angles, it's at an angle theta, and so based on your question options down here, we need to see if B and C do not take into account the angle. So we need to think, do we care if that angle is changed or not? Is that going to change the EMF? And the answer is yes, because the more field lines the conductor cuts through, the more EMF is going to be generated. So we do care about the angle. The angle does matter, so it's not B or C. Now the only thing that we need to do is we need to decide what this L is, because we've got B and V in both of them, and we've got sine theta in both of them. So we've either got X, which is from tip to tip of the wing, or we've got L, which is from tail to nose. And the wire, if you're moving a wire or a conductor through a magnetic field, as we just said, it's how many field lines it cuts through. The nose to tail is not going to be cutting through any if the field lines are vertical. The wings are going to be cutting through field lines, and so we must only care about X and not L. So D is the correct answer there. Question 20 is D. This was part 2 of the second IB multiple choice paper that I've been going through. You can check out the links in the description for the link to the playlist for the other videos, and also the link to the unanswered questions if you want to have a go at them yourself. Thanks very much for watching.